Hello everyone and welcome to today's video. We will be going today through some of the latest questions from the subject of air law. I'll show you some real life examples and I'll try to also share some resources with you in order for you to understand the topics better, and hopefully this will help you with the exam and the general ideas behind the questions. So let's just jump into question number one straight ahead. The MOC, or the minimum obstacle clearance of a minimum safe altitude, or the MSA, is. And of course, the correct answer here will be 1,000 feet. This is one of these easy points that if you know, you know. And of course, it's also good to remember what an MSA is. MSA will be a radius. It can be an altitude or two altitudes or even more within 25 nautical miles of, in most cases, the aerodrome reference point, in which area you are guaranteed at least 1,000 feet of obstacle clearance above the highest obstacle in the area. So just a quick reminder that an MSA, I'll show you a real life plate here, to which we'll go into in a next question as well. However, I just wanted to show you here on the right side, you can see there is an MSA MSA box, and you can see that, for example, in Saloniki in Greece, we have two MSAs, 4,500 on the western side and 5,500 on the eastern side of the aerodrome, and this is 25 nautical miles as a radius. And also remember that, generally speaking, all of these different altitudes, so the IFR altitudes that you need to know, like the minimum en route altitudes, minimum off-route altitudes, they all can be found and their definitions in your Jepsen introduction glossary. I have an electronic version that I can show you real quickly here of the Jepsen Airway Manual. And as you can see in the glossary section, if they are available in your authority during exams, then take advantage of them. You can clearly see the definition of an minimum en route altitude, as well as your MORAS, your minimum vectoring altitude, and your minimum sector altitude, or MSA, or minimum safe altitude as well. And you can see the definition that it will provide you a minimum clearance of 1,000 feet above all objects located in that area, contained within a sector of 46 kilometers or 25 nautical miles, centered around radio aid to navigation or the aerodrome reference point. And sometimes, if this radius is centered around a fix, it can be called a TAA. So in that case, it can be centered around an intermediate or initial approach fix. Going into question number two, so according to ICAO PANZOPS 8168, which is our IFR Bible, a traffic advisory TA should precede a resolution advisory because, now of course, it is not a requirement. If you are heading into traffic, or you are starting to climb or descend very rapidly with traffic below you, an RA resolution advisory can sound immediately, skipping the TA. However, a TA inside of your cockpit will give you a warning, a sound of traffic. In that case, depending whether your aircraft is equipped with automatic TCAS or autopilot TCAS or not, the pilot will usually either call out the changes of the FMA or will assume control. However, the TA, the traffic advisory on its own, doesn't warrant any action. It's only the RAs that do. So of course, the TA will highlight the approximate position of an aircraft nearby that may become an array. Remember that the TAs are generated if an impact is potential within the next 40 seconds, and the resolution advisories take over when the aircraft is 25 seconds away from us. And here I just wanted to show you a quick photo, quick graphic of a navigation display of an aircraft, and on which you can see all the symbols related to the TCAS with threatening and not threatening, proximate, intruder, and the array traffics. And as you can see next to, for example, this white diamond right here, you can see the arrow which indicates that the aircraft is currently climbing, as well as -11, which means it's 1,100 feet below us. Going into question number three, so which types of airspace are included in an FIR? So an FIR, is a flight information region. You can think about it as a country. So this is a general airspace of a state. Some countries, as I'll show you in just a second, can be divided into more than just one FIRs. However, within those FIRs, we will have all the airports, the CTRs, the TMAs, as well as different classes of airspace. So as you can imagine, if you think about an FIR SA country, you can imagine they can have all types of controlled airspace. However, they do not have to have them. So remember that many countries will have only 3, 4 different types of airspace within their FIRs. It is not mandatory to have all of them, and most countries will not. As promised, I wanted to show you, this is a map that I found from 2024 from the Eurocontrol website. And as you can see, this map lists all of the effective FIRs within the Europe region. These are very important, and not only for your flying and to know in which airspace you are. Obviously, this is very important. However, remember that the FIRs are responsible for search and rescue within their territory. And this is vital for ensuring safety and good organization in aviation. And this is one of the reasons why these FIRs play such a pivotal role. And as you can see, no place is left without its assigned FIR. And this is because of the search and rescue efforts and reasons for which these countries pledge to conduct if necessary. So this is something just to remember. And as mentioned before, you can see here Germany. Germany is divided into 2 different FIRs, into Rhine on the southern side and Hanover on the northern side. So going back to the question bank, so now going into question number 4. According to ICAO Doc 4444, which is our ATC Bible now, when an aircraft is radar vectored to an ILS localizer course, the angle between the interception course and the localizer course should not be larger than. So, of course, this is a question that is relatively specific, but you need to know 2 different numbers for these questions. Normally speaking, you should not be vectored to a interception course or interception angle of more than 45 degrees. This is generally too much, and you'll see that especially if you fly manually, it will make incredibly difficult to catch the localizer without overshooting it. However, if you are conducting an independent parallel approach, for example, in that case, this can be even lower the interception angle. The interception angle in these cases has to be 30 degrees. So remember, for independent parallel approaches, 30 degrees, and for all others, essentially, it will be 45 degrees. When it comes to these numbers, I also wanted to remind you that, generally speaking, you should be vectored to at least 2 nautical miles before your final descent point, which in a lot of cases will be your final approach fix. And lastly, there's another number that is good to remember, which is 4 nautical miles. 4 nautical miles from the runway, you are not you cannot receive any speed control instructions from the ATC, as essentially they cannot tell you to maintain a certain speed. 4 miles is the 4 miles is the cutoff distance. So remember, 2 miles for the vectoring, 4 miles for speed control, 45 degrees for a vectoring and interception course, and 30 degrees if it's an independent parallel approach. Question number 5. Except when necessary for takeoff or landing, or except by permission from the appropriate authority, what is the minimum height to be maintained by an aircraft over the congested areas of cities, towns, or settlements? So this is a relatively tricky question, as I'm sure you can, at this moment, you are already thinking about the minimum VFR altitude, which would absolutely be the correct thing to do. However, remember that the ICAO annexes, they actually stipulate that your minimum height to be maintained by an aircraft over congested areas, towns, or settlements will be a height that will permit an emergency landing to be made without undue hazard to persons or property. And that's a period. And that's really it. However, of course, EASA has built up on this even more. There are different altitudes for IFR and VFR flights. So, of course, IFR flights are not permitted to fly outside of the IFR published routes or procedures unless vectored. However, the VFR flights have their own minima, which you need to maintain. So, of course, in order to stay legal, besides having a height that will permit an emergency landing, you also need to maintain those minimum VFR altitudes, because sometimes you might say that actually the minimum VFR altitude will not permit you an emergency landing to be made without undue hazard to persons of property. In that case, you need to apply the more conservative altitude. And I'll show you the minimum altitude here. Of course, you might remember already, you always need to be at least 1,000 feet above the highest obstacle within the range of 600 meters of a congested area. And if the area is unpopulated, meaning in most cases not a city, then 500 feet above the highest obstacle within that range will absolutely be okay. Also remember the visibility, which is required 5 kilometers, and above flight level 100, you're required to have 8 kilometers. And these are relevant for your VFR minimum altitudes. However, generally speaking, you need to have a safe height that will permit you to fly safely, especially during emergency. So number 6, an aircraft has been instructed to descend from flight level 330 to flight level 110 or 11,000 feet altitude. When should the pilot change to QNH? So actually, this question is twofold. So first of all, by law, the moment you're cleared to an altitude or the moment you are cleared to a flight level, you actually are allowed legally to change to either your standard pressure setting or your altitude. However, remember that the altitude is there for you to be safe of terrain, mainly when you are flying low. And of course, the standard pressure setting is there for traffic separation. So for these reasons, it's always good to maintain your barometric reference as such, unless until particularly necessary. It is a good practice to, when descending from a high altitude, to change to your QNH near the transition level, because sometimes ATC can also tell you to level off at a certain flight level, even if they cleared you to an altitude before. So in order to avoid continuous changing of your altimeter settings, it's good to always do this later. However, by law, you can do this once the clearance has been given from the local ATS or ATC, because remember, the QNH is always given for the local station, as these pressure reference can be different for different places, and it's usually linked to a certain aerodrome or a certain weather station. Also remember that if the QNH is much lower than the standard pressure setting, it is possible that you will actually overshoot your altitude when descending and changing to the QNH. So this is just something to keep in mind when flying and changing when the QNH is much different than the SPS. And now for the last question, number 7. So if a missed approach is initiated prior to reaching the missed approach point, what should the pilot do? And of course, the correct answer here will be proceed to that point and follow the procedure. So actually, the missed approach point is something that we will use if we fly, in most cases, non-precision 2D approach. It is something that used to be very relevant when doing the dive and drive approaches, meaning first you descend to your MDA and then you continuously fly level until the missed approach point. And then if you see the runway, you land. And if you do not see the runway by missed approach point, you simply go around. However, now EASA mandates that we do continuous descent final approaches, the CDFAs, in which case we will change our MDAs into derived decision altitudes. In most cases, we will add a certain amount on top of the MDA to have a derived decision altitude. In that case, usually we will do an go around if we do not see the runway by the DA. However, I just wanted to show you on this chart. This is again the chart in Saloniki. So this is a chart which gives you a non-precision approaches. So LNAV VNAV, which is a 3D approach, and LNAV mandate CDFA approach, which is a 2D approach. You can see these arrows, these dictate your DA. So this shows you where, when using the decision altitude, where your go around will be. However, the big M marks a missed approach point. In case you do decide to level off at the MDA and continue until you see the runway, you can do so all the way to the threshold, because if you don't see the runway at threshold, you need to go around. However, if something happens and you decide to go around before that, it's absolutely not a problem. You simply follow the missed approach procedure, which in the case of this Jefferson chart will be outlined here, meaning flying via this RNF point to feet low, climbing to 3,000 feet. So you simply follow that procedure via the missed approach point anyway. And just lastly, just to show you the difference between, this is an RNP Yankee approach, which has an LPV, which is essentially a precision approach, which or can be considered as such, as flown to the Cut 1 minima. As you can see here, for example, we do not have the missed approach point. We only have a DA and the arrow that dictates where we would potentially go around in case that is necessary. In any case, this will be everything from my side. Thank you so much for your attention and joining today's video. I wish you all the best with the exams, and I hope to see you in the next one. Thank you and bye-bye.